So now we're going to get into solving some word problems that result in a quadratic equation. So what we're going to do is we're going to find a couple different ways that we can use words to represent x squared, or squaring a variable. And sometimes it comes right out and tells us, like in this first one here. 5 times a positive number subtracted from the square of the number is 66. Find the positive number. So what I'm looking for here is I'm looking for a positive number. So I usually like to start off by defining my variable. I write down like a let statement. So x is going to represent my positive number. So now when it says 5 times a positive number, I'm going to write down 5 times a positive number. Subtracted from. Ooh, be careful. That means that I'm going to take something and subtract this 5x. So my minus sign goes over there. What am I subtracting it from? The square of the number. Okay, so what number? Well, my variable x. So the square of that number. And what is that expression equal to? Well, it is 66. So look at that equation. Solve it using a method of your choice. So what I'm going to do is I'm going to set it equal to 0 and factor. I think that's a nice thing to do right here. Let's try that. I think what I'm going to do in this video is I'm going to show a couple different ways to solve it. So now I'm going to do some factoring. Let's see, I'm looking for 2 numbers that multiply to 66 and combine the negative 5. How about x minus 11 and x plus 6? So now I use my 0 property. I'm going to get that x equals positive 11 and x equals negative 6. Those are my 2 answers to the equation. But the question said to find the positive number. So what that means is I don't need my negative number. So in this instance, I'm going to cross that off. I'm going to reject it. I don't need that answer. So what's my answer? My positive number is 11. Notice that they didn't ask for both answers. They only asked for one answer. Find the positive number. So I write down the positive number only. Let's keep rolling. Now we're talking about the length of a rectangle. Well, let's draw ourselves a rectangle. I'm going to assume that my length is my longer side, and it's 6 meters more than the width. Well, do I know how big the width is? Not really, so let's call the width x. Now the length is 6 meters more than the width. So what if we call the length then x plus 6? Now we're then told that its area is 72. So think about it. How do we find area? Area is another one of those key things that tells us to multiply. Area is length times width. So if I take my length and my width and multiply them, I'm going to get 72. Take a minute. Solve this equation using a method of your choice. All right, so I'm going to distribute on the left side and get x squared plus 6x. And I'm kind of noticing that that's almost ready to complete the square. So I think I'm going to do this one by completing the square. So I take my 6, I divide it by 2, I get 3, and I square it, and I get a positive 9. So let's put a plus 9 in there. Then when I do my factoring, I get the square of x plus 3. 72 plus 9 is 81. I take my square roots of both sides. I get x plus 3 equals plus or minus 9. Let's subtract 3 from both sides. So I get x equals negative 3 plus or minus 9. Let's see, is that going to come up again? Negative 3 plus or minus 9. So remember, I get 2 answers here. So one of them is negative 3 plus 9, which is 6. The other answer is negative 3 minus 9, which is negative 12. So let's go back to the question for a minute. It said, what are its dimensions? Ooh, good word there. Dimensions are the length and the width together. Tell me what the length is. Tell me what the width is. So length and width are positive measures. So again, I'm not going to need that negative 12 as my answer. So what if we then say that the width is 6 And now the length is 6 more than that. So 6 more than 6 is 12. The width is 6, the length is 12. Check it. 6 times 12 is 72. That's my area. I'm looking good, man. Let's keep rocking. Here we go. Boom. One positive number is 3 more than another. Oh boy. So before we even go any further than that, one positive number is 3 more than another. Well, so let me call x one of them. And then what if we say that the other one is 3 more than that? So there's one number and the other number. That's an ugly looking other, but we're going to move on with that. Ooh, check this out. It says the sum. Okay, sum means add. So I'm adding things together. What am I adding together? Their squares. Whose squares? Well, the square of my two numbers. So I'm going to square my first number, and then I'm going to square my other number. So the sum of the squares is 89. Interesting here. Well, let's see if we can solve this. I'll kind of walk you through the beginning of it. That x plus 3, that thing squared, I think I got to multiply it twice. So when I do my distributive property, I'll get x squared plus 6x plus 9. So check out what I got now. X squared plus 6x plus 9. And that's over there. Plus x squared equals 89. Alrighty, let's see what we're going to do here. Maybe I'll set this equal to 0 by subtracting 89. I'm also going to combine some like terms. X squared and x squared give me a 2x squared plus 6x minus 80 equals 0. So when I look at the left side, I'm thinking, you know what? It looks like there's a greatest common factor of 2. So let's divide everything by 2 or factor out that 2. Whoops. When I divide everything by 2, I get x squared, I get a 3x and a negative 40. All right, now I got to keep factoring though. So what if I factor this to x plus 8 and x minus 5? And I'll bring that 2 down. So now I got to do my 0 property. So check this first one out for a second. I'm going to set my factors equal to 0. One of my factors is 2. Does 2 equal 0? No. So don't worry about it. Let's just drop off that 2. Oh, why did we drop off that 2? Well, does 2 equal 0? No. So cross it off. So from here, we're going to get 2 answers. We'll subtract 8 and get negative 8. We'll add 5 and get x equals 5. Now it says find the 2 positive numbers. Okay, another situation where I get rid of my negative. Do I always get rid of the negative? No, but if they say they want positive numbers, you keep positive numbers. If they say find the 2 negative numbers, you get rid of the positive. So let's see. X is the first number, x equals 5. The other number is x plus 3. That's 8. There's my 2 numbers. Pretty cool. So now I want to introduce you to a couple of my friends. My friends are called the consecutive integer family. Say hello. Hello. So consecutive integers, consecutive, meaning one right after another. So numbers like 3, 4, 5, 6. Numbers like negative 4, negative 3, negative 2. They're all consecutive integers. So what if I call the first one x? Ha ha ha. Well, to get to the next integer, it looks like I'm going to add 1 to it. And then to get to the next one after that, I'm going to do x plus 1 plus 1. But wait a minute. It's really just 1 more than the previous one. So it's x plus 2 and x plus 3. So here's how we represent consecutive integers. If the first one is x, the next one's x plus 1. The next one's x plus 2. Oh, I kind of get it. So if I have consecutive even integers, and I'm using numbers like 10 and 12 and 14, they go up by 2s, right? So then in general, I can call them x and x plus 2 because they go up by 2's. Yeah, you got it. Next one will be x plus 6 and so on. Oh, and consecutive odd integers. So are you thinking they're like x plus 3, x plus 5? No, they're not. But wait, those are odd numbers. Hold on. Look at numbers like 5, and then 7, and then 9. How do you go up by those? They have a difference of 2. So consecutive even and consecutive odd integers are represented the same way. So let's use a consecutive integer problem in here. So let's say we want to find two positive consecutive integers whose product, ooh, here's another good word, product. Product is when you multiply. So we've got to multiply things together. So if I remember from before, consecutive integers were like x and x plus 1 and x plus 2 and x plus 3. So if I call my first consecutive integer x, int for integer, how about my next one being x plus 1? They're positive and they're consecutive. So their product, let's multiply them. X times x plus 1 equals 132. All righty, why don't we distribute, set it equal to 0, and solve it. Whoa, did you see what I just did there? Let me show you. After I distributed, I subtracted 132. Let me do it in steps. So I get x squared plus 1x, or x squared plus x. And now I'm going to move that 132 to the other side. So I get x squared plus x minus 132 equals 0. Now let's do factoring here. I'm looking for two numbers that multiply to 132. That combined to give me a 1. So that means the numbers are, well, they're consecutive integers, right? So how about things like 10 times 11? No, that's not it. How about 11 times 12? Yeah, that works. So how about x plus 12, x minus 11? We set our two factors equal to 0. One of our answers is x equals 11. The other answer is x equals negative 12. What are we looking to find? Two positive consecutive integers. So again, this is time we don't need that negative one. So what are our two positive integers? Well, we said x was 11, and x plus 1 is 12. There we go. So in this lesson now, we're learning how to write quadratic equations. Because once we can write them, then we can solve them.